Well, good day, everybody. This is Greg Freeby. I'm the Executive Director of the American Segmental Bridge Institute. We're going to go ahead and start our webinar at the top of the hour. We have a good program for you this morning. Looking forward to remarks from Dr. Natassia Brenkus. Hopefully that's what you're here for, is our September webinar. And before we get there, we'll do some introductions. Again, I'm Greg Freeby. I'm the Executive Director of the American Segmental Bridge Institute. I'd encourage you to follow me on LinkedIn if you're not already, and also encourage you to follow the American Segmental Bridge Institute. We've really been using social media a lot more in the recent months to help communicate some of the events we have going. Of course, you can always go to the American Segmental Bridge Institute website to find the latest information, but you'll also get some regular updates and some project lookbacks and just sort of what's going on in the industry by following us on social media. Some quick announcements. Our October webinar is October 27th, 2021. That'll be from noon to 1 Central Time. The folks from ARP are going to join us to talk about design and construction of concrete segmental extra-dose bridges. They'll be using the most recently completed bridge, the Rose Fitzgerald Kennedy Bridge in Ireland, as sort of the backdrop to talk about extra-dose segmental bridges. Not a real common bridge type in the US. We have a few of them, but this will be a good feature to learn a little more about this bridge type. This will be the last webinar we do for this year, and we'll resume then our Wednesday webinars, as we're calling them, the last Wednesday of each month. We'll be resuming those in February of next year. Just another little reminder, we have our 2021 convention coming up in Tucson, Arizona. If you haven't already registered for the convention, I would encourage you to do so. We have a really good technical program set up. We'll have our committee meetings on the 6th and the morning of the 8th, and then the convention proper will begin on the afternoon of the 8th and run through about noon on the 10th. We have a great technical program set up, great facility, opportunities certainly to social distance, and even participate in some activities outside. So some quick instructions about the webinar. If you lose connection, you can rejoin the webinar, and kind of like when you walk out of a live conference, an in-person conference, you're going to miss content when you walk out. But we'd encourage you to log back in if you can. If you have trouble getting logged back in, you can always send an email to the info@ASBI email address, which I'll show here in a minute, to help you with that. We will be issuing certificates for attendance to those who do meet the minimum time requirements for attendance, and expect, if you'd be so kind as to wait about a week before you inquire about your certificate. It usually takes us about a week to go in and verify attendance by all of our attendees and issue certificates. We will be doing Q&A at the end of the presentation, and we'll talk about how that works. We're going to be using the feature within GoToWebinar to allow you all as attendees to submit questions. You just type them in to the little question box here. You can see an illustration of how this works. You just click the little questions pane, type in your question and submit it. The question will then go to me, and then at the end I will serve as a moderator to work with Dr. Brenkus and kind of walk through some of the questions that you all had. Hopefully we'll have time to follow to hit all of the questions. If not, we'll certainly try to follow up with you with answering questions by email. If you're on a mobile device, the interface looks a little different. You should have a little question mark, and you can hit the little question mark, and then a little dialogue will come up for you to be able to submit a question. This webinar is meeting RCEP requirements for continuing education. Again, we will be issuing RCEP certificates for those who meet the minimum time requirements for attendance. Before we introduce our speaker, I will remind, if you go to our website, you will find that all of the previous webinars have been recorded. And so if you'd like to view, or you missed one of the webinars, you can view those. They're just a little quick registration and link to be able to view the webinar. Unfortunately, we can't issue certificates for participating in watching a video, but certainly if you're a state that has an honor system, you can certainly use those for professional development hours, and also there's some great information there to receive as well. So with that, I'm going to introduce our speaker today. It's Dr. Natassia Brenkus. She's an assistant professor at The Ohio State University. The focus of her research is on innovative materials and improved structural performance and durability of concrete bridge systems. And she has a particular focus on post-tensioning systems, which is great for us here today. Her research has been funded by the likes of the Precast Prestressed Concrete Institute, the National Academy of Sciences, the American Concrete Institute, among others. And her research is really motivated by this. She has a very strong interest in advancing concrete design for the practitioner. Today, she's going to be sharing with us today the research she did through NCHRP Synthesis Study 562, which is titled Repair and Maintenance of Post-Tension Concrete Bridges. And so if I would do my job and step over and make Natassia the presenter, and you give her just a minute here to bring up her screen, and then she can begin the presentation. There you are. All right, we see your screen. But maybe we still have you on mute.
Can you hear me now?
Yes, we can.
Classic question. All right.
Yep, absolutely. It's the question of 2021.
Good afternoon, everyone. Thank you, Greg, for the introduction. Again, my name is Natassia Brenkus, and I am an assistant professor with The Ohio State University. As you mentioned, I will be presenting today on our research group's efforts to put together a report for the NCHRP program on the repair and maintenance of post-tension concrete bridges. So just to orient everyone as to how these projects work or these research efforts, highway administrators, engineers, and researchers may often face problems for which there's already information and it's either documented or it's floating around out there in fragments. And so synthesis efforts are undertaken to create a systematic assembly of that information and provide it to the highway community as a service to inform their practices. This particular project then was an effort to gather information on the repair and maintenance practices of post-tension bridges, both in service and those actions occurring during construction, with the aim of facilitating knowledge transfer across agencies so that the information can inform bridge owners' repair and maintenance practices in the future. So this synthesis is 5114. It was published in 2021, and following the general format of these efforts included a literature review of the state of the art, a survey which was distributed to state departments of transportation, as well as 5 case studies going into some depth on 5 separate structures that had undergone some post-tensioning tendon repair and other actions to the PT system. Post-tensioning as a technology has been utilized in the U.S. bridge construction industry since the 1950s and has seen many improvements over the years. Recently in the United States, repair and maintenance actions have gained additional interest and attention due to some instances, although few, of serious tendon degradation in structures primarily that were built prior to the year 2000. Since the early 2000s, the industry has made significant advancements to improve the quality of PT structures, taking a number of actions to improve the grout materials that are utilized as fillers, improving quality control and injection procedures, as well as creating certification and education programs for personnel. Agencies continue, however, to address issues in both older and newer PT structures, and the need for continued improvement remains. So we issued a survey to the state departments of transportation, and that survey had a scope to include the aspects that may contribute to a repair need later on in the structure life, aspects related to design, construction, inspection, and maintenance. We distributed an online-based survey to the 50 state departments of transportation in February of 2020, and we had participation in some forms, a response from every single state, which is fantastic. And so we had our survey in February of 2020, and then we followed up with communications with each Department of Transportation for additional clarification and some deeper questions. Of the 50 states, 5 responses were partial or incomplete. But from the other 45, we have some valuable information. So I wanted to paint a picture of the pool of respondents of the survey that I will give some information about in the next several slides, and so that we all understand the pool of who's responding. There were 44 state agencies that report having post-tension structures in their inventory. 6 states do not have any PT structures, including Arkansas, Iowa, Maryland, South Dakota, Tennessee, and Wyoming. Of the states that don't have a PT bridge structure, several reasons have been provided, including a lack of familiarity with the technology, concerns related to quality and durability, a lack of need for such a structure, and as well as a lack of local established industry presence. The number of post-tension structures varies widely. Some states have no or few structures, and others have many hundreds. So just to give, from a broad picture perspective, the experience, if you will, based on the inventory of a State Department of Transportation is pretty varied. At one end of the spectrum, California has nearly 3,000 PT structures, and on the other end, several states such as Delaware, New York, Rhode Island, and South Carolina have 5 or fewer. Okay, so I think I have a duplicate slide. We have the scope of the survey, which is, now that we understand the pool of respondents, we'll turn to a discussion about the information that we gathered in the survey. So a series of questions in the survey were aimed at identifying efforts by the various state agencies to ensure that or to understand where they are in terms of the current and up-to-date practices. So the survey covered multiple stages of the PT structure life that could contribute to later need for repair, including design, construction, inspection, and maintenance stages. Questions were asked related to agencies' PT-specific specifications, for example, the inclusion of protection levels from a designer's perspective, quality control and assurance practices during construction, etc. In general, there was not a uniformity in approach in the responses that we received from the state DOTs, and with a wide variety of guidance, with a variety of guidance documents that were referred to different certification programs and different design approaches. This variety is not particularly surprising if we think about the wide range of PT experiences that exist from state to state. Of the states with PT structures, the type included in their inventories was also varied. So we have 44 states here in the US that have PT structures. They range from segmental bridge structures, which are found in a majority of the states in responding as to whether or not they had PT in their inventory. 24 states have cast in place segmental structures, and 30 report having precast segmental structures. Right, and you notice, as shown in this bar graph, quite a few of them have performed some type of repair on each type of construction shown here. Most states have updated their specifications in the past 2 to 7 years. So agencies were asked to specify the documents that they were referring to when they created their specifications. This helps us understand where they're getting their information and how old that information may be, or how current that information may be, as well as who they're turning to for advice. So the state specifications in general, according to the respondents, have generally been informed by guidance documents such as the PTI ASBI M50 guide specification for grouted PT, the PTI M55 specification for grouting of PT post-tension structures, and the AASHTO LRFD bridge construction specification. A notable number of the agencies are modeling their PT specifications from a couple states. And so what I mean by that, there are 7 states that refer back to Florida DOT's specifications when they write their own specifications, and there are 4 states that refer to California's. There's another trend in which some states lean on the specifications of their neighbors and when they're creating their own documents. In general, though, the specifications are reflecting that the dissemination of lessons learned since the 1990s and the early 2000s have made it into the specification documents of each state. We asked agencies to identify whether or not they were utilizing what's known as a protection level design approach. So this is the idea that we would identify the severity or the exposure category of a structure during the design process, and we would make decisions regarding durability aspects and detailing to accommodate more aggressive environments. Right? So this is a concept that is espoused in the FIB documents for durability consideration during design. And so when we asked agencies whether or not they were utilizing this this is not a common practice here in the United States. Most states, or 23 of them, that have post-tensioning in their inventory are not indicating a requirement for a particular protection level. Only some states are specifying such a thing, either through a direct specification or through equivalent requirements that would be associated with this idea of a protection level. One state is in the minority. Michigan is requiring the most stringent protection level for its PT structures, which is known as a PL3 protection level. In terms of construction, one aspect that has been contributing to the improvement of PT structures is the use of certification programs. And so important improvements to the end product quality of a PT structure and its durability later on in its service life are in part attributable to the development and increasing use of these certification programs. These programs, of course, are aimed at training and educating the personnel engaged in the construction of PT structures, as well as the inspectors and the plants that provide the materials specific to PT. Some states require that personnel have attained such certifications, including most notably the ASBI grouting certification is fairly frequently required by states in order to engage in PT projects. And some states go one step further, establishing their own training and qualification programs. The issues related to cementitious fillers, in other words, grouts, which may be non-proprietary or proprietary, have been well documented in PT structures since the early 2000s. Grout deficiencies in external tendons have been documented in several structures, and we have a couple of the case studies included in our synthesis report. When grout issues occur in internal tendons, that is an order of magnitude more difficult in terms of addressing them with the repair actions. And so these are significant concerns. Causes of poor quality grouts have been identified through owner-instigated investigations and various research efforts by different teams across the country, and have been identified. Some of the things that may contribute to poor grout quality include things like underweight bags, which affect the mix proportions, improper mixing technique, improper injection procedures, and more recently, some light has been shed on the effect of grout storage and handling procedures. And so agencies were asked whether or not the agency had specific grout storage requirements, and more than half responded in the negative. Recent research efforts out of the University of Florida by Dr. Trey Hamilton have identified that susceptibility of grout to premature unintended hydration in the instances of improper storage. So this is something of note, that despite the identification of this source, many states are not indicating specific storage requirements at this time. Regarding inspection practices, so later on in the structure life, many states are not many, a majority of states are primarily relying on visual inspection by the personnel not specifically trained or with experience in PT and its nuances. Many states have performed non-routine inspections of their PT utilizing invasive techniques or attempting NDT, so non-destructive testing aided approaches. Many states have also investigated through research programs the potential or feasibility for utilizing NDT in their inspection efforts, right? So, but at the end of the day, most of them are still relying on visual inspection. So next we'll turn to talk about the repairs more specifically. We asked each state about their experience regarding repairs. A majority of the states, so 23 of those that have PT structures, so 23 of 44, have experience with some form of post-tensioning tendon or PT repair, excuse me. Repairs are most often performed by contractors, especially when the issues are of an extensive nature or require some specialization. Some states occasionally, such as New Hampshire and Oregon, have performed repairs with their in-house staff. We were interested in asking about what would instigate a repair, quote unquote PT repair. 17 states report having conducted a PT repair during the construction stages. So this is when things are most often occurring. But another 10 states have performed repair actions due to identification of corrosion in the PT structure. Only one state reports having performed a repair related to a vehicle impact, and another 9 repair associated with deck repair and replacement. Looking at the types of repairs performed, the states identified a multitude of repair actions. And so this is what is shown on the slide. I won't go over each of these, but there are a couple things of note. There are 6 states that have performed an external tendon replacement, or at least is reporting that they have performed one by the respondent. 17 states have performed crack injection to a PT structure. What I find interesting is that 13 states have a report having repaired a pourback or an anchor blockout, that detail that is of critical importance when we think about post-tensioning tendon force delivery to the system. There are quite a few states that have repaired that area when we asked in the survey. A number of states have utilized, as I mentioned before, NDT aided inspections. So there's 17 states out there that have looked into this. So if you're working for a state agency that is considering that, know that there's quite a bit of experience out there in this realm. Finally, another thing of interest, there are 13 states out there that have regrouted tendons, and an additional 6 states that have strengthened a system through some means to address corrosion and impact damage. So diving a little bit deeper, we wanted to ask about that stage of construction, which has been identified as a period of the most repair actions being performed on a PT structure. So we were looking for trends encountered during the construction stage, and we asked agencies to identify potential causes for later repair, asking them to comment on particular aspects of PT construction, and we used the word problematic to cue that they were having issue with the following things. We asked if they encountered certain construction details as problematic, whether or not they found problematic construction techniques or methods, or materials specific to PT construction. And so of the responding states, so 35 states went on to answer this set of questions. Nearly half of them report issues with problematic, quote unquote, construction details. We asked them to identify those details that they'd encountered issues with. Most commonly, they're reporting issues with duct splicing details, anchorage pourback details, and confinement reinforcement. So, not surprising, many of these details are related to geometry alignment and may are not necessarily something that you wouldn't encounter in another type of bridge construction. 6 states identified other details of concerns that they had encountered in the construction of their PT structures, including issues with large shear keys that cracked during erection, conflicts with blisters and deviator geometries, again, other concepts related to alignment and geometry, including concerns with the sharp corners and deviators that led to kinking or damage of the tendon duct. So several of the case studies that we went on to go into in our synthesis revealed duct conflicts at diaphragms and deviator locations as a recurrent problem that occurred before modifications to connections and refinement of the standard practices, which occurred in the 2000s, improved these details. So there have been some moves in practice, or there have been some changes to the practice that have improved this, but agencies are still having to manage the structures that exist from the time period before that. One recent detailing shift instituted in the state of Florida in 2014 could provide an additional solution to other agencies, and that's the utilization of what's known as a Diablo-shaped deviator type. This void form is gentler in slope, but it has a gentle angle change that at the entrance to the deviator void that could ease the transition of duct profiles at these locations. So respondents less frequently identified construction techniques and methodology as problematic, if you'll allow me to continue using the term, suggesting that recent efforts to educate the personnel engaged in PT structures through these certification programs may be proving to be beneficial in improving the state of the art. So of the 36 people that responded to these questions, 12 told us that yes, some construction technique or methodology of concern, some construction technique was of concern. So issues identified by those states that thought that there was something to see here, and talk to us about grout filling procedures, air pressure tests, vacuum tests, etc., all of which are occurring during the injection process, right? One state stressed rather emphatically that it was important to have personnel requirements in order to ensure that those people working on the grouting procedure during grouting were properly educated and had the experience in order to make this in order to ensure the end product quality. 15 of the respondents reported dissatisfaction with specific materials used in post-tensioning, with the primary material of concern being that grout filler material that we mentioned earlier. So other states did talk to us, though, about issues with the pour-back materials. Again, looking back at the detail around the anchorage, they described these materials as difficult to apply or resulting in later shrinkage cracking. So this, I'll also note that the flexible filler material, no state has reported any issues with that, but then I'll just say that that's not surprising given that this type of filler material is a recent introduction to the US bridge industry. States reporting issues with grout filler materials, I'll go on to say that they provided further comment suggesting that their response to us was informed by issues of the past before the introduction of pre-bagged thixotropic grouts. Several states called specific attention to problems with excessive bleed water and chloride contamination, again mentioning structures that had been constructed before the 2000s. So I'll go on to describe, we conducted 5 case studies that I will point the listeners to. If they have significant interest in the details of each one of these situations, I'll point you to Synthesis 5114, and I'll talk about a few here. We looked at the Wonderwood connector in Florida, at the Wando Bridge in South Carolina, the Veterans Glass City Skyway here in Ohio, the Varina-Enon Bridge in Virginia, and finally the Plymouth Avenue Bridge in the city of Minneapolis. So I will highlight a few of these. We talked to the Florida Department of Transportation about the Wonderwood Connector. This is the Wonderwood Connector Bridge that is located to the northeast of Jacksonville. It's a 0.7-mile long post-tensioned I-girder structure with internal tendons. It was initially built in 2002 to 2004. And what is going on with this particular case study is that after the identification of some chloride intrusion in other tendons in other bridges, utilizing the same grout that was injected into this structure, the bridge owner ordered an invasive inspection of a limited number of tendons and found some corroded ducts and soft grout. The bridge is currently undergoing extensive repairs following a series of inspections that revealed additional tendon corrosion and severe grouting issues. So at the time of the writing of the synthesis in summer 2020, the repairs were underway, and there are a couple interesting aspects to this particular case study for agencies that may be interested, including a particular interest, that they are trying to remedy grout issues with internal tendons in continuous I-girders. So the agency has approached this through first drying the tendons to remove residual moisture, and by injecting a proprietary corrosion inhibitor for additional corrosion protection. Finally, they will add additional strengthening to the system through the installation of additional external tendons. And so one thing that we saw in a couple of our case studies is this idea that has now been utilized in a couple of structures, or a couple is probably not the correct word, but it's this idea of tendon impregnation using a proprietary material that is acting as a corrosion inhibitor. This material is injected from a side port into the tendon, which is, of course, filled with a grout filler material that is in some way compromised at certain locations, but we can't get it out of the Wonderwood Connector Bridge. And so instead, this tendon impregnation approach allows this low viscosity material to flow along the interstitial spaces in that 7-wire pre-stressing strand and permeate out into the grout to provide additional corrosion protection. The Wando Bridge in South Carolina, this is the I-526 bridges over the Wando River. These are a pair of precast post-tension box girder structures spanning between Mount Pleasant and Daniel Island, South Carolina. The construction of these structures occurred much earlier in the mid to late 80s, so before many of the lessons learned that are now employed, improving the state of the art. And so routine inspections by the bridge owner were occurring through the early 2000s, and they were reporting out that the bridge was in good condition, although these white deposits were regularly noted and attributed to what they were saying was pigeon droppings. So significant water intrusion in 2010 coincided with the initiation by the agency of an external asset management contract, and an in-depth inspection was conducted, which revealed a multitude of concerns, including a suspected tendon loss, as they inferred from inferred from spalling and leakage in one of the piers. So a series of inspections and repair actions have been undertaken to address issues with these structures over the years. As of the time of the writing of the synthesis report, additional repairs were underway. With most repairs complete, the bridge was opened. This isn't yet another example of a structure that is utilizing a corrosion inhibitor injection as another form of protection for the system. They were also working on installing a quick deploy inspection and repair setup inside of the box girder bridges to address any future issues. And so finally, in terms of the case studies, I will point out different example of an issue with a PT structure or a case study of some PT repair that has been performed by the Ohio Department of Transportation on the Veterans Glass Skyway, which is over the Maumee River in Toledo, Ohio. And so this is a critical section of I-280. And again, this is a relatively recent structure built between 2002 and 2007. This bridge has many innovative features, but our topic today treats the bridge wearing surface, which was integrally cast with the section. So the girder was cast with a 2-inch thick integral wearing course, and then another 2.5 inches of supposedly of concrete clear cover. And when the Ohio DOT attempted to replace that integral PT deck, they uncovered issues, which is that there was insufficient concrete cover protecting the transverse tendons, and on further inspection, these transverse tendons were insufficiently grouted. So the project, they're attempting to replace the bridge deck by milling off 1 inch of the overlay and hydro demolishing the next 1/2 inch in order to get that rough surface for resurfacing. As they attempted to perform the demolition, however, they were exposing these transverse tendons in the top flange in more than 70 locations. So the agency hypothesizes that the voids are the result of improper duct filling, which contributed to duct damage when they came back when they were coming through with the hydro demolition. Locations of the duct damage are currently undergoing repair, which is a multi-step process and involves further water blasting to remove the loose debris, epoxy over the exposed strand, and then providing a rough surface with the application of some sand, finishing off with a final concrete cover layer. So this bridge, it was partially open at the time of the writing of the synthesis in last summer. This project, if you're interested, has grout issues with transverse tendons in the integral PT deck and a couple instances of improperly filled tendons that the agency is attempting to address. So, I put that out there for agencies that may be looking at similar scenarios. So the synthesis takeaway, just a couple of bullet points that we found of interest in our work. One, the consideration of durability during the design phase is currently not practiced as widely as perhaps may be desired, meaning that from the design stage, we are not looking at things from the perspective of the long-term durability and the assignment of a protection level for these structures. There remain some issues with methods of construction, as we previously discussed, most often related to grout and filler injection and duct pressure testing. Finally, I'd like to again note that routine inspection, as we came to describe in several of the case studies, the routine inspection was insufficient to identify issues with PT structures before they became critical, and so I would recommend that inspection be performed by personnel with specific PT experience to further facilitate the identification of problems before they become more severe. So with that, I will conclude. If you would like additional detail, I believe actually that it is included as a part of the GoToWebinar as a handout. If not, if I'm mistaken, the NCHRP synthesis report is available on their website. So thank you, and I'll stop there.
Well, thank you, Natassia. Yes, you're correct. We do have the synthesis report available as a handout as part of the webinar, and also I should be able to drop a direct link to it in the chat everybody should be able to access. So I just dropped that in. But again, it's also available as a download in the interface here, and as a handout. And again, I think Dr. Brenkus had some sage advice, and that the case studies really provide some really good information for owners that might be, I'll say, facing maybe similar situations, or just a good knowledge base. So we did have one question that came in the early part of your presentation, and that is, could the states that had a lack of PT specification but used project-specific PT specs be a reason for the high number of responses saying they do not have one?
They do not have a specification.
Yeah, I guess earlier you had a slide about the number of states that had PT specific specification, a statewide, state spec for post tensioning, and I think the question is, and I know it's kind of supposition, but could it be because they don't have a statewide spec, but they do specific, project specific specs for this kind of work?
Yeah, I may have, did I take away the screen sharing? But to answer that without showing the slide again, the protection levels, when asked that, we gave them the option of telling us that they utilize project specific protection levels. Is that what we're talking? I'm sorry, or are we talking about specifications?
I think we're talking about specifications, but let me see if I can make you go back to making you the presenter again. And you might then be able to back up to that slide. We're just seeing a blue screen right now.
Okay. I'm struggling to find the slides, but I mean, I think that's a fair point.
Right.
That is another possibility, that they're providing specifications on a project by project basis.
Right. Well, and I can sort of add to that, having been involved with some projects that were constructed recently, where the owner did not have a statewide, they don't have in their construction specifications a specification for post tensioning, and so project specific specifications were developed for the project, and just candidly, and they were apparently done so using some older versions perhaps as go-bys, and they certainly weren't referring to the current PTI ASBI specifications for grouting specifically, and that they called for flushing of the ducts with water, which that is a practice that was suspended some 20 years ago in recognition that you're never going to get the water back out of the ducts, and so now you've introduced water that's just going to further mess up your water cement ratio in your grout, because it's going to be absorbed into the grout as you're grouting. Ideally, the thixotropic grouts that we use today do in fact push out a lot of that water, but deliberately introducing water into a duct is not advisable. And so it's a little segue to say, yes, there are project specific specifications, and when an owner or even a designer uses those, I would caution and make sure, if the reference documents you're using to create those are current specifications, industry standards, particularly the PTI ASBI specs. So yeah, I see you have your slide up now about protection levels, and I think if you would, that does sort of warrant a little more discussion about your findings in terms of what you learned about owners and protection levels that were specified.
Yeah, I just wanted to say that I think maybe we're talking about the specific detail in terms of specification, not whether or not a state has PT specifications in general. And so there are only a handful of states that are utilizing project specific protection level specification. The majority of the states do have some form of PT specifications in place.
Okay. So then it's really
That
more
makes
about
any
the
sense.
it's more about the protection levels, not
Yeah,
the
this,
specifically
yeah,
like the plans don't say must conform to PTI ASBI, protection level 2 or whatever, right?
right. So, yeah, that was not clearly described when I was going over this slide, but in this particular instance, we're talking more specifically about the protection level concepts, yeah, that the PTI has included in their documents.
Right. I got you. Actually, I think it's probably more my misinterpretation of the question. So, all right. So thank you. And we have a couple more, of course, these are always kind of hard to the questions about a study that's already closed. Do you know, are there any plans to take this study kind of to the next step, which would be to ask similar questions of designers and contractors and even installers to get their feedback on common issues from their perspective?
I I think that would be a worthwhile effort that maybe I'm not sure which industry group might want to undertake that, but that from the perspective of that side as opposed to the bridge owner, those questions remain. Yeah.
Right. Yeah, I think that would actually be a really good follow on. So then we had another question about on the case study projects. As part of that, did you discover anything about there being any issues in terms of developing the contracts to quantify I'll say the scope of the damage to provide plans and specifications for the repair work so that a contractor can put a price on the work?
We didn't go into that aspect
Okay.
of their response. No.
Right. Yeah. And I know that's, I will just say from my personal experience while I was at the DOT, that's always the challenging part of a repair project is you think you know the quantity of or the extent of what you're going to do on a project, but then when you get into it and start, removing material or sounding further right, you start finding you get a little bit of scope creep, and I know it's a challenge to do that then in terms of a traditional design bid build, right? How do you quantify? And I will say when I was at the Texas DOT, we would set up a contract so that we quantified as best we could the scope of repairs, but then had it set up so that certain items were paid by the each or by the linear foot or what have you, so that as we discovered more repairs perhaps needing to be done, then there was a unit price or a bid price, right, to basically rework the contract to pay the contractor for that additional work. To try to do a repair is sort of like a lump sum. That certainly puts a contractor at a lot of risk, particularly, again, as I said, when you get into these, a lot of times the scope kind of creeps a little bit just because you find things.
Yeah, we did talk to them about these same issues that you are discussing, which is you're not necessarily sure what you're walking into with the external tenons, and if there are issues with the grout that were uncovered in some of the invasive inspections were performed. You're looking at like discrete locations along a tendon, and then when you get in there to do the repair, that scope creep could occur. But so far as how to address that, we didn't go into that with them.
So I guess my question would be, so then does that somewhat relate to the inspections themselves? And you made the comment earlier on that the sort of the traditional inspections are probably not, the routine inspections are probably not sufficient for really evaluating a post-tension structure. And I guess then it sort of follows that then that inspection is also not really sufficient to develop a set of plans for doing repair.
Yeah, I think that's a good point. That of the case studies that we're looking at, often the owner is turning to someone with additional expertise in PT in order to develop a deeper inspection and understanding of the situation before they go on to repair the system, and so that becomes a critical element. But it seems that contacting those people with that expertise and having them perform the inspections isn't happening until there's something critical going on, as opposed to earlier on in the structure life.
Right, understood. And so in that vein, because you also mentioned then NDT techniques, and I know this wasn't necessarily the part of the, but can you say anything about NDT? I mean, what are there some resources that folks could seek out to sort of try to assess what the best NDT methods might be for a given situation they may be looking at?
Oh gosh, you're going to stretch my memory.
Okay.
Yeah, so we covered some of the NDT methods that have been utilized when it comes to PT specifically. So these are like tools in a toolbox and how they get applied to PT. It varies in terms of how well it can tell you information. And I would say like there's no technology that is like the answer. But a number of research groups have done more extensive studies than what we did in terms of the feasibility and the efficacy of a particular NDT technique. So I would defer back to some of the other researchers that have done that, and we call attention to several of them in the synthesis to try to help bridge owners identify those.
Right.
Sources.
Okay. Yeah, I that's what I seem to recall that there was part of the synthesis sort of talked about some of the NDT techniques that are available, and I certainly echo your view that there's no silver bullet here, and it may take a number of methods to really do an assessment. So I'm looking to see if we have any questions then that have not been answered. So this is y'all's opportunity, folks. We have a few more minutes left. If you have any more questions you want to ask, please feel free to do so. Guess in the meantime, I will hop back over.
Do I need to give you permission?
No, I've got it back. So just as a reminder, the study is there is a link in the chat, and then there's also it's in the handout as well. And then if time goes by and you kind of forget about it, you can literally just web search for repair and maintenance of post-tension concrete bridges, and this will probably come up as an early hit. But we do have somebody did come in with one more question, and we'll go ahead and field it before we wrap up. So, and I imagine this is going to vary, but how long after construction were problems seen in the case study bridges?
So we looked at 5 structures, and the short answer is it varies widely depending on what we're talking about, because we included structures that such as the one here in Ohio that had been built in the early 2000s, but the repair specific to that is something that was uncovered only recently, and maybe wouldn't have been seen if it hadn't been for attempting to replace the deck. So I think the question is motivated by like how long, like, do we need to wait before we start to see problems with the structure? And I'm not sure that there's a good answer to that. So like even the bridge, the Wando Bridge that I had up on the screen that was built in the 80s, they were documenting some issues in their inspections prior to the 2000s and well before any repairs were performed, right? So it kind of runs the gamut.
Right, understood. Yeah, and I will say just sort of the observations I have sort of seen across the country are a lot of times there's some early indicators, and it wasn't until they really kind of, I'll say, dug a little deeper where they found the extent of the damage, and those early indicators are, whether it's the efflorescence or some staining, or, I will even cases where they discovered there's water inside the segmental box. Well, that's an indication you have joints leaking or water coming from somewhere. and so corrective actions kind of need to be taken, and the longer you wait, then the worse that damage gets. So, and I think that is, there's one more question. This is about timeliness. It says, on average, how long did repairs take, i.e. how long was the bridge out of service?
I do not think I can answer that question.
Right.
The repairs that we were talking to agencies about were still underway at the time, and in some cases it had been going on for a little over a year or a couple of years, depending. But
Right.
I'm not sure.
Okay. Fair enough. So I will thank you all for attending today's webinar. And again, I'd encourage you to follow the American Segmental Bridge Institute on LinkedIn. Also, if you have questions or comments about this session, you can send an email to the email address you see on screen. Sorry, apologies about the formatting. It went kind of weird for some reason. It's the info@asbi-assoc.org. And again, if you'd wait about a week before inquiring about your certificate for attendance, we should be getting those out here like within a week at the most. If it runs a little longer than a week, then certainly feel free to send an email and check about the status of your certificate. So, Dr. Brenkus, I thank you for your time this morning or afternoon, and really interesting project. And I think, at least from my perspective at the American Segmental Bridge Institute, it's sort of a little bit of call to action in terms of it kind of points us in a direction of maybe some of the homework we need to do yet to help states and owners as far as improving the quality of their post-tension structures. I think a lot of the technology is out there. It's just a matter of bringing it to bear and getting it into the marketplace. So again, thank you. And with that, I guess I will end the webinar. Thank you, everybody.
Thank you, Greg. And thank you, everyone.